This right here is the legend Joey Chestnut. Every year he competes in the Nathan's hot dog eating contest on the 4th of July, and he's won almost 20 of these competitions consecutively. He is the best professional eater of all time. In 2025, Joey Chestnut ate 70 hot dogs in just 10 minutes. And so I went through and I watched the video and I plotted how many hot dogs he had consumed after each minute and made this graph here. So let's talk about the independent and the dependent variables, right? So the number of hot dogs he's able to eat obviously depends on how much time he's given. So my independent variable would be the time, and the dependent variable would be the number of hot dogs. So let's think about what these mean. So he started with 0 minutes and had a total of 10 minutes. So we went from 0 to 10 minutes. Similarly, he started with 0 hot dogs and he finished with 70 hot dogs. So he went from 0 to 70 hot dogs. And this is what we call in mathematics domain and range. When we're looking at a function, we want to see the horizontal and the vertical distances of graphs. So the domain is the horizontal distance of a function, and range is the vertical distance of a function. Okay, so the domain measures the horizontal axis, which is all of my x values, and the range measures the vertical, which is all of my y values. And so when we're looking at functions, we've got some different types. If we have 2 endpoints, we're going to measure between 2 numbers, right? So I'm going to do my domain in blue here, right? So what I want to do is I want to go from left to right. So I start with whatever my leftmost value is. And I'm going to put an open circle here because that's going to affect my inequalities in a second. And then I go all the way to this closed circle here, which is going to be my rightmost point. And so the horizontal distance is all of these numbers in between here. So I'm going to shade along the x-axis. So all of the x values in this function are between my leftmost point and my rightmost point. And so we're going to use inequalities to measure in between these, right? Inequalities are just like those alligator mouths that you probably learned about in elementary school. And so there's kind of 2 different types of inequalities that we could have. We could have less than or greater than, or we can have less than or equal to and greater than or equal to. To say equal to, we use this line underneath it, okay? Whenever we're working with inequalities, if we have an open circle, we do not put the line underneath it. All other times, we do have the line. So for this domain and range for this function, I would have an inequality here, but since I have this open circle, I would not put a line underneath it. And my range, I would put my rightmost point, I would have a line underneath there because we have a closed circle there. For my range, I'm going across here and I have an open circle at my bottom point. So domain is going from bottom to top. And so my highest point is right here at this closed circle, which is my topmost point. And so I want to measure the distance here. And so I'm going to shade along my y-axis like this. Again, we're starting with the bottom point. I have an open circle there, so there's no line underneath my inequality. My range is going to be all my y values. And then my topmost point is the end. Since there's a closed circle there, I'm going to have a line underneath my inequality. Sometimes, however, we're only going to have one endpoint and the graph is going to continue in some direction forever. So for this one, my domain, I have this leftmost point here with this open circle, but I see that this arrow is pointed to the right forever. So I'm going to travel along my x-axis and never stop going to the right. When we just have one endpoint, we're going to have x and some number. And thinking about the alligator mouths that you used to work with in elementary school, are all of these x values bigger than or less than the leftmost point? Well, all of these numbers going this way would obviously be bigger. So the alligator wants the bigger snack, which would be going towards all of these x values. I have an open circle here, so I'm not going to put the line underneath that inequality. My bottommost point is right here. And I see that this arrow is going upwards forever. So I'm going to travel along the y-axis forever like that. So I have y and my bottommost point. Again, all of the y values are bigger than this bottommost point here. So the alligator mouth wants to open towards the bigger snack. And again, since I have this open circle, we are not going to put the line underneath that inequality. And my last example here, my domain. This time I see that the graph is going left forever, but I do have a rightmost point right here. Actually, that should be in blue. And so for my domain, it's going to be all my x values compared to my rightmost value. I see that the graph is going this way forever. And since we're going to the left, all of those x values are smaller than my rightmost value. So that means R would be the bigger snack. So the alligator mouth, the inequality opens that direction. Since we have a closed circle, we're going to put the line underneath that inequality. My range, I have a highest point this time. So this would be my topmost point. This arrow is going downwards. So I'm going to shade all of these y values going downwards. So my y value and my topmost point. Again, my topmost point is the highest value. All of these numbers would be smaller down this way. The alligator wants the bigger snack, so I would open towards the topmost value and put the line underneath the inequality since we have this closed circle. So remember, we use just the regular less than and greater thans when we have an open circle. And all other times we're going to use the line underneath it. Okay, let's do some examples with some actual numbers here. So let's find the domain. So I see my leftmost point, this has two endpoints, is right here, and that's at -1. And my rightmost point is right here at this open circle, which is 1, 2, 3, 4. So all of the x values in this function are between -1 and 4. They're all greater than -1. Since that's a closed circle, I would put a line underneath the inequality, but they're still all less than 4. I have an open circle there, so I do not put the line underneath that inequality. For my range, I'm starting with my bottommost point, which is this one right here, and that's 1, -2. And my highest point is right here at this closed circle, which is 3. And so all of my y values are between these 2 points. So between -2 and 3 are all my y values. This time I'm starting with that open circle. So I want all the y values greater than -2, but less than or equal to, since I have this closed circle, the y value of 3. Let's do this next example now. My leftmost point for my domain is right here at -1 again. And I see that I have this arrow to the right, so that means I'm going to continue along the x-axis forever. So x and -1. All of my x values are all bigger than -1, so the alligator mouth would open this way. And since we have an open circle here, I do not put the line underneath that inequality. My lowest point is right here at -3. There is not an open circle there, so I'm going to put a closed dot like that. This arrow goes upwards forever, so I want all of my y values up to infinity. So since all of these y values are bigger than -3, I'm going to put the line underneath the inequality like that and say -3. And now my last one. I have a arrow going to the left and an arrow going to the right. So I don't have a leftmost point or a rightmost point. If that's the case, I'm going to say this is all real numbers. Same thing with my y. This arrow is going down forever and upwards forever. So it is also all real numbers. So I hope you had as much fun as I did learning about domain and range. Good luck in your practice, and I'll see you in the next video.